All right, so your 4.3 notes. Our goal today, we're going to start matrices, which matrices just kind of look like a table, but they don't have all of your rows and columns drawn in, like the lines that separate them. Instead, you have brackets that make it a matrix. And then you do have rows and you do have columns of numbers. Okay. So our goal for today is going to be to analyze data into matrices and to perform algebraic operations with matrices. And our main goal that we're going to be working towards is we're going to learn kind of these basic things with matrices, and eventually what we're going to do is we're going to learn how to write a system as a matrix, and then what we'll be able to do is we'll be able to solve a system using matrices, and then that way you can use your calculator, because when we are solving systems in 3 variables, there is a way to do it on a graphing calculator, and as long as you have that Calculate 84 app on your phone, or that emulator if you have an Android, the emulator is Wabbit, okay, then you're able to use the matrix calculator on there to solve a system. So we're going to learn these basics about matrices, and then we roll back to solving systems and combining it with matrices. So what is a matrix? A matrix is a rectangular array of numbers that written with square brackets. An example would be matrix A. You name a matrix with a capital letter. This matrix has 4 columns and it has 3 rows. Okay, so this would actually be a 3x4 matrix. Because there are 3 rows. 1, 2, 3 rows, and there are 4 columns. And when we write our dimensions of our matrix, it's rows by columns. So that's how we write the dimensions of the matrix. A matrix element is each number in a matrix. So this actually has 12 elements as part of the matrix, because there are 12 different locations or 12 different numbers that are a part of that matrix. We can denote a matrix element by saying from the matrix above, locate. If this was a capital A to name the matrix, our element would be a lowercase a, and then 1, 4 is just like a coordinate point almost. But rows come first, and then columns come second. So this would be row 1, column 4. And you write them just out like a book. So rows, this would be row 1, this would be row 2, this would be row 3. This would be column 1, 2, 3, 4. So always write left to right or top to bottom. So rows 1 to 2, columns 1 through 4. So this is row 1. So you're on this top row, column 4. So 1, 2, 3, 4. We're talking about the number 5. That's the element, is 5. So next it says from the matrix above, locate A, 2, 3. So this would be, actually I want you guys to do this one on your own. See if you can find row, whatever, column, whatever. So if it's A, 2, 3, what row is it from? What column is it from? What is your number? So you should find row 2, column 3 is located at element 4, and it's this 4, the one that's in row 2 there. Okay. All right, so analyzing data in a matrix. So the first thing that we're going to do is we're going to organize this data into a matrix. The data is Latino population in the U.S. in millions, and it gives us age groups, gives us the number of males, the number of females. And so our data that was actually collected is, find a highlighter, is all this information right here. That's the actual data. So when we're asked to organize that into a matrix, when we put just that into the matrix, we need a 4x2 matrix. So on the top row, we're going to have 7.1 and 6.6. So we're just organizing the data that was collected as a matrix instead of a table. So there's your 2x4 matrix. So then it says add the elements in the columns and interpret the results. So our columns are the male column and then the female column. And we're going to add them up to figure out the total in the male column versus the female column. So when we add these up, in the male column, we're going to add 7.1 plus 6.8 plus 3.2 plus 1.1, and we're going to get 18.2. And in the female column, when we add this one up, 6.6 plus 5.9 plus 2.2 plus 1.4, we're going to get 16.1. And then it says interpret the results. Sometimes the results do not have meaning. Okay? Sometimes they do. And so that's what you kind of have to decide is, can we interpret these results? What is the total 18.2 actually meaning here? And in this case, it's the number of males in all the age groups, because you go from 0 to 19 to 20 to 39, 40 to 59, and 60 plus. So if you're adding up all of those groups, you're finding the number of male Latinos in millions in the United States. So this number right here says that there are, depending on when this data was taken, 18.2 million Latino males in the U.S. And then we can use the 16.1 and write a very similar sentence. There are 16.1 million Latino females in the U.S. And that just depends on when that data was taken, in the year, whatever. Next it says to add the elements in the rows. Okay, so we're going to add the 7.1 and 6.6 together. So when we add up these totals, I'm going to write C above because I'll just write this next to the chart. The total here, 7.1 and 6.6, adds to 13.7. And the next one, 6.8 and 5.9 add to 12.7. 3.2 and 2.2 add to 5.4. 1.1 and 1.4 add to 2.5. Are we okay with those totals? And then it says to interpret these results. So when I interpret these results, you're just adding the males and females together. So the total number of Latinos in the age group of 0 to 19 is 13.7 million in the U.S. Okay, so we're doing age groups there. So there are 13.7 million Latino aged 0 to 19 in the U.S. And then we're going to have 4 sentences very similar to that. So I'm just going to go like this. 12.7 million, 5.4 million, 2.5 million Latinos age. The next group would have been 20 to 39. This one would have been 40 to 59, and this one would have been 60 plus. So as long as you have one sentence, I know that you are understanding. You can just tell me what the next ones you would fill in. I don't need you to write 4 complete sentences. If you want to, sure, that's fine. Yes. The next says, would finding the average of the rows or columns provide any meaningful data? So a lot of times what happens is if you find a total and it's meaningful, sometimes the average is not going to be meaningful. Sometimes both will be meaningful. Usually it's like one or the other, though. That would be meaningful data. If I average the 7, 1, and 6, 6, my total was 13.7, so I would divide that by 2. I would get 6.85. It doesn't really make sense because the males and females are just 2 groups. So you could say that the average number per gender in a specific age group would be those averages, but it doesn't really make sense to do that. Okay, it's not really telling you meaningful data. You'll notice that, like, in your assignment, you'll be finding, like, average gas mileage. That has more meaning when you're talking about gas mileage. If they take a bunch of data and then you find the average of it, you can say that the average gas mileage for this type of car is such and such. And that's a normal average to find to figure out a gas mileage of a vehicle versus number of people in a certain gender. It doesn't really have meaning. Okay, if we figure out the average for the column, you'd add up your total. The total was 18.2. Divide that by 4. You'd be saying that there's an average of 4.55 million Latinos per age group. But that really doesn't make sense either because, well, it just doesn't. This is 20 years. That's 20 years. That's going to be 20 years, or technically 19 years. But this one is an indefinite number of years because it's 60 plus. So it doesn't really make sense to find those averages. They're not really meaningful data. You could find the averages. You can do that, but it doesn't really create meaningful data. So. All right, so that's enough with the data analysis. Now we're going to actually work at doing operations with our matrices. So when we add and subtract matrices, to add or subtract 2 matrices with the same dimensions, add or subtract their corresponding elements. Now when you add or subtract, they have to have the same dimensions, okay? If you have A and B, what we're going to do is we have to first write out our problem. So our A matrix is -1, -8, 3, 5, 4, -2, plus our B matrix, which is -5, 3, -4, 6, -2, 3. What we are going to do is our answer, we can only add them if they have the same dimensions. What are the dimensions of this first one? What are the dimensions of this first matrix? How many rows? 2. How many columns? So it's a 2 by 3 plus a how many rows, how many columns in the second one? A 2 by 3. So since you have a 2 by 3 plus a 2 by 3, you can do that, and your answer is also going to be a 2 by 3 matrix. And you'll see why this is important after lunch, because there are other weird situations that happen when we multiply matrices after lunch. So our answer is going to be a 2 by 3. This one you can show a workbox if you want. I'm not going to be super picky about it, as long as you have something kind of written. But your workbox would be you're adding an element in this location is going to put your answer as the element in the same location. So when you add it, you're adding -1 plus -5. That would be in that element, meaning your answer would be -1 and -5 is -6 is going to be the element in that location. Okay, the next one, that middle box, is going to be -8 plus 3. -8 plus 3 is -5 in that middle box. The top right box is going to be 3 plus -4. And 3 and negative 4 together is negative 1. Five and 6 together is going to be 11. 4 and negative 2 is going to be 2. Negative 2 and 3 is going to be 1. And that would be your final answer. You added matrices if you got to here. Give me a 1 to 5. That seems like I could do that on my own. Down to 1, I have no idea what these brackets and numbers and where any of this is coming from. Okay, so we're going to do this next one. This next one is b minus a. So we're going to write out b. B is negative 5, 3, negative 4. A is 5, 4. Oh, shoot. I'm still writing b. Sorry. Second row in b is 6, negative 2, 3. Minus the a, which is negative 1, negative 8, 3. On the bottom, 5, 4, negative 2. It gives us what the matrices are up at the top. Did we see that? Okay, so that's our problem that we're given. You should always write that out because you want to make sure you're looking at it. Then we'll write our work box. Now, last time we were adding because it was an addition sign. But now we have a subtraction sign. Okay? So in this first box, we're going to have negative 5 minus negative 1. Negative 5 minus negative 1. The top middle is going to be 3 minus negative 8. The top right is going to be negative 4 minus 3. Do you guys see how I'm getting these expressions in there? Okay, the bottom left is 6 minus 5. The middle, negative 2 minus 4. And 3 minus negative 2. And then what I'm going to do is now I'm going to actually do each of those, simplify each of those expressions. So negative 5 minus negative 1 turns into negative 5 plus 1, which is negative 4. 3 minus negative 8 turns into 3 plus 8, which is 11. Negative 4 minus 3 is going to be negative 7. 6 minus 5 is 1. Negative 2 minus 4 is negative 6. 3 minus negative 2 is 3 plus 2, which is 5. Are we okay with how I got that? So there's your final answer. Give me like a 1 to 5. I think I can add and subtract. I'm getting that. I can handle that much. Okay. That's the hardest part about this lesson. Okay. The next is a scalar. And a scalar is just a constant that is in front of the matrix. So to multiply a matrix by a scalar k, multiply each element by k. So in this case, your k value is actually 3. 3 is in front of the matrix C. Your matrix C is 1, 3, 2, 6, 5, 3. Okay. Now what you're doing is you're going to multiply every single element by the scalar out front. So your workbox here turns into 3 times 1, 3 times 3, 3 times 2, 3 times 6, 3 times 5, and 3 times 3 because you're multiplying each of the elements by 3 because 3 was your scalar. So our answer is 3 times 1 is 3, 3 times 3 is 9, 3 times 2 is 6, 3 times 6 is 18, 3 times 5 is 15, and 3 times 3 is 9. Give me a 1 through 5. I think I can handle scalars. Okay, with that, I want you to try B on your own right now. Try B. All right, so this is what I got. I got a 2 by 3 is my answer. In the top row, I have 10, negative 6, 8. The bottom row is negative 12, 4, negative 6. Give me a 1 to 5. How'd that go? Awesome. Awesome, awesome. Okay, so the next one, I lied to you. I said number 1, the adding and subtracting is the hardest that it gets. But number 3 actually puts number 1 and 2 together. Okay? So it gets maybe just a little bit difficult, a little bit trickier. Okay, now I'm going to show you how you can rewrite this. And this is just, when did you guys learn negative numbers? Back in like 5th grade? 5th or 6th grade? 6th grade? Okay, so this is going to take you back to 6th grade because subtraction is negative numbers. So isn't it true that I can write this as 3c plus negative 2b? Are you okay with that? Okay, then 3c was actually the answer that we got in 2 part A. Right? 3c, we already figured that out. Now, if I were to just say that, let's say C and B were just numbers, it's the same idea. Let's say I gave you something like this, 3 times 6 plus negative 2 times 4. PEMDAS tells you that you have to do the multiplication first, and you have to get 18 plus negative 8, and then do the adding or subtracting to get that your answer would be 10. Correct? Is that okay? So the same idea works with matrices. You have to do 3c and negative 2b first, and then you can add those answers together. So 3c, we actually already did that problem. The cool thing about this unit is I will probably do like partial work in previous problems. But you have to be careful because if you get those wrong, then you could get things wrong as we keep going. Okay, but 3c was the matrix 3, 9, 6, 18, 15, 9, plus negative 2b was the matrix 10, negative 6, 8, negative 12, 4, negative 6. Is that okay? Are we okay with this, how I got this problem? How I turned 3c plus negative 2b into this problem here? Okay, so then since we're adding a 2 by 3 and a 2 by 3, our answer is going to be a 2 by 3. Maybe we'll want to do our workbox first. So we're going to have 3 plus 10. In the middle, we'll have 9 plus negative 6, 6 plus 8, 18 plus negative 12, 15 plus 4, and 9 plus negative 6 is my workbox. And then underneath that, I'm going to have my actual answer. 3 and 10 is 13. 9 and negative 6 is 3. 6 and 8 is 14. 18 and negative 12 is 6. 15 and 4 is 19. 9 and negative 6 is 3. So this here would be your final answer. How does that look? Give me like a 1 to 5. I think I can handle this section down to a 1. Whoa, matrices. Let's just watch The Matrix. Just kidding. Has nothing to do with this, I don't think. I've never watched it. No, I've never watched it. It's a good movie?